So let's talk about your three types of power, or your three types of AC power. So let's erase this. AC power. Okay. What are the three types? So we're going to go over the symbols here. So the first type is, you got a type, symbol, unit, or units, and description. So the first type is real power, right? Like when you're really powerful, okay? And the real power, its symbol is P, okay? Its unit is watts, okay? Or WKW. And the description is the power that you use. So it's used, or usage, or power usage. Let me find another word for it. It's consume power, right? What you're going to consume. So it's consumed. I can't even spell. Let's do this again. Consumed power. Or usage, right? It's usage. Now, the second type of power, well, I'm sorry, before I go into that, real power is also called average power. Okay? You have real power, you have average power. They mean the same thing, right? The second type of power is called reactive power. Okay? Reactive power. And in reactive power, right, your symbol is Q. Your unit is VARs, or kVAR. Okay? And this is really your unused power, right? It's unused power. And it's created from the magnetic field, right? So when your electricity is running, generally it creates a magnetic field, and that magnetic field releases what you call reactive power. Okay? And another name for reactive power is, you can call this power, is imaginary power. Right? You imagine you have that power, but you really don't. Okay. So last but not least is your total power. Okay? And in this total power, right, the symbol is S. And we have what you call VA or kVA, right? Now, understand that the units for watts, it's really VA. Units for VARs is really VA. But we designated for these different units because of the AC line, right? So if I say 1000 kVA, I'm meaning total power. If I say 1000 watts, I mean real power. Okay, even though technically the units are the same. Now, the description of this is a total, but it's not like you add them. So you really can't add them together, right? So it's really designed for this. You have what you called a triangle, and this triangle has an angle. So your real power runs along the x-axis. Your imaginary power runs along the y-axis, and your S is your hypotenuse, right? So when we see it, it's basically described as S, right, is equal to P squared plus Q squared, square root. This is your Pythagorean theorem. If you remember that in algebra, right? So use your Pythagorean theorem to get your total power. But there's a little different way to do it also, right? So we want to describe something else as well. Before I get into that, another description, your total power is also known as your complex power. Okay, it's complex number because reality, this is a complex number because this is really the imaginary component. So your y-axis in power electrical engineering tends to be your imaginary component induced from your magnetic field, or the y-axis of your triangle. Your real component is usually your x-axis in the triangle, and your total component is your S. So this is called a complex power from a complex component. Now, last but not least, you have apparent power. So apparent power complex power and total power mean the same thing. So how do we relate this to real life? So imagine you're going to work. Imagine you're going to work. So how many hours a week do you work? You work 8 hours a week, right? Let's just say it takes you an hour to get there and an hour back, right? So that's 2 hours, but your total time is 10. Now, in reality, you're working 8 hours, but you have to work that total 10 because you have to drive to work 1 hour each way. So 8 plus 2 is equal to 10. So in that spectrum, this is how total power works, okay? In that area. So